The camera's red spectrum is ready to transmit one of the most powerful laser shots in human history. All systems are checked and waiting for the order to turn the target into ashes. 3, 2, 1. And a powerful laser beam is sent to its target across the entire White Sands missile range. This test, conducted this spring, is a significant step towards the future combat use of the 300 kilowatt HELCAP laser. While the previous systems were designed to blind, this one is designed to completely destroy with a powerful energy charge. But how did this become possible? Laser weapons have long ceased to be fantasies and expensive concepts. Nowadays, lasers perform a wide variety of missions around the world, and the United States has made the greatest progress in their development, of course. U.S. laser systems are used at sea and on land against small targets and large ships. The importance of this weapon is growing every year, and today you'll learn the declassified details of the test of the best laser system on which the United States has spent more than $1 billion. And for good reason, because in modern warfare, the winner is the one who destroys the target more efficiently and cheaply. The cost of a laser shot depends only on the energy source. Thus, the most expensive part of this weapon is development. And then there are the tests, the details of which often become so interesting that they're hidden. The first U.S. laser weapons tests in the 1990s reveal many fascinating details that have been partially declassified in recent years. The airborne laser program was launched in 1996. It involved the installation of a powerful chemical laser on a modified Boeing 747-400F. The aim was to destroy ballistic missiles in the initial phase of flight. Years of development culminated in successful tests in 2004, when the laser was able to accurately target a missile in motion. These tests gave rise to the technology of shooting down missiles, which is now being used throughout the Western world. The biggest problem that modern engineers are trying to solve is sufficient power and energy supply for the laser. Along with this technology, an even better idea was being developed. The HEL program appeared in cooperation with Israel in the late 1990s and was aimed at developing a ground-based tactical laser to protect against artillery and missile threats. In 2000, the HEL system successfully shot down several artillery shells and missiles during tests in the Nevada desert. The data from these secret tests gave impetus to the development of Israel's laser program, which is now successfully protecting the country's borders. The next program created a whole myth around it. In 2002, the ATL program was launched to install a solid-state laser on the AC-130 aircraft. The main purpose of this development was to create high-precision laser systems capable of destroying or disabling enemy targets from a long distance. The test confirmed the possibility of using a laser to destroy ground targets from the air. The problem with this technology was the lack of a high-quality cooling system and high power consumption. Perhaps the use of this particular laser was noticed in Asia, after which the possibility of a laser attack frightened people so much that they came up with improvised ways to protect themselves. At one time, there was a widespread myth that buildings in China were covered with blue awnings to protect them from laser radiation, as the color blue supposedly reflects laser beams. However, the reflection of laser radiation depends more on the material of the awning than on its color. This hardly makes any sense for modern high-power lasers. However, the most shocking tests are waiting for you right now. The pinnacle of secret developments was the Miracle laser, which was designed to destroy air and space targets. In 1997, the Miracle successfully destroyed an old satellite in space, which was the first test of its kind. However, this technology was never developed into a real weapon. Changes in the military and political situation, the complexity and high cost of working with chemical lasers put this project on the back burner. The same cannot be said about the idea of influencing the weather and even burning forests with lasers, which is still actively discussed on the internet. Although there are international agreements such as the UN Convention on the Prohibition of Military or any other use of environmental modification techniques, which prohibit the use of weather modification technology for military purposes, this technology is being actively studied by armies around the world. At the University of Arizona, scientists have conducted experiments using powerful lasers to create plasma channels in the atmosphere. They used ultra-short laser pulses to ionize air molecules and create condensation nuclei to form water droplets. Simply put, it's about using a laser to create rain, and given the saturation of UAVs in modern warfare, this technology is quite suitable for the military. Also, researchers at the University of Central Florida are currently working on a technology to discharge electrical charges in storm clouds using powerful laser pulses. They've created a system that directs ultra-short laser pulses into storm clouds to cause lightning to discharge safely. However, this is not a secret military research, but rather a purely scientific one. However, there are numerous conspiracy theories claiming that forest fires are caused by laser systems. However, there's no scientific evidence that such technologies are used for this purpose, and no such case has ever been documented. All these developments, both civilian and military, contribute to the development of laser technologies. Decades of military development have resulted in near-perfect systems, such as the Directed Energy Maneuver Short-Range Air Defense, which is mounted on the Stryker armored vehicles and has shot down drones in Iraq, and the Layered Laser Defense, which has successfully destroyed a variety of targets, including unmanned aerial systems and speedboats. We should also mention the new MLD system, which is designed to protect against missiles and other aerial threats and is capable of tracking and destroying targets at incredible speeds. During one of the tests, the MLD destroyed a drone in just 2 seconds, and in another test, it was able to stop a simulated missile threat, showing how effective it can be in combat conditions. These systems are widely publicized in the media as the most advanced developments in laser technology, but none of them would have been possible without little-known and often classified programs. $100 million of taxpayers' money was spent on various projects that often ended in failure. Those developers who succeeded in their plans moved progress forward. What does the future hold with this pace of development? Most likely, in the near future, laser technologies will be able to work with ballistic missiles to shoot down previously unattainable targets, such as supersonic missiles, massive attacks with unguided projectiles, and massive drone attacks. Military developments in the civilian sphere will help to influence the weather near airports, drought, or hurricane areas, but the impact of such interventions in nature will still need to be studied. And how can we do without the scary theory of Star Wars in space, especially after Russia's statements about its desire to deploy nuclear weapons to shoot down satellites? Laser weapons are an incredibly important technology that changes the rules of warfare. Laser systems are capable of destroying targets at a great distance, doing it instantly. Moreover, many systems can destroy numerous targets at once, so you can't beat them in quantity. You must admit that this greatly affects the tactics of war. Previously, it was enough for the enemy to launch as many drones and missiles as possible at one point, so that the old air defense system just didn't have time to destroy everything at once. But in truth, not all types of laser weapons are equally effective against the same targets. Let's analyze all the currently known lasers, and you'll find out what they're capable of. It's important to understand that each type of laser has its own unique characteristics and applications that make them indispensable in certain fields of science, technology, and medicine. The laser you use to play with your cat also uses a specific technology. For example, did you know that your grandmother's ruby can be turned into a weapon? Ruby crystals are used for solid-state lasers, and the power of such a thing is enough to blind an enemy and turn off electronics. But there are other options, such as semiconductor lasers. I bet you have one at home. If I win the argument, you'll subscribe to me and like me, okay? So pick up the TV remote control. Do you see a red light at the bottom? Congratulations, you've found a semiconductor laser. And if you don't have a remote control, the tiny hole on the top of your phone is also a laser. And finally, gas lasers. Hold on, what? Is gas used to make a powerful beam that burns through steel? Yes, technically this is true. I'm not going to explain the technology because it's boring, but remember, this type of laser is used in the most powerful weapons.
Which we can just fire using a laser weapon and have on our platforms is potentially going to be much cheaper.
Nevertheless, laser weapons, despite their advantages, have several significant disadvantages that limit their use. Lasers require enormous energy consumption to generate a powerful beam. Currently, there are no compact and efficient energy sources capable of providing long-term operation of laser weapons. The United States has made an attempt to fix this by creating a miniature system that can be recharged, but its power leaves much to be desired. The high power of lasers also generates a significant amount of heat. Cooling of such systems requires complex and massive cooling systems, which makes the weapon bulky and difficult to operate. But this is being actively worked on. Moreover, the energy of the laser beam decreases with distance due to scattering and absorption in the atmosphere. Dust, smoke, rain, and other atmospheric conditions can significantly reduce the effectiveness of laser weapons. You can see for yourself that the record range of a laser does not exceed 6 miles, which is a pity.
The range is limited. It's more limited than the range of interceptor weapons.
It's also important that laser weapons need to hold the beam on one point for some time to hit the target. This can be challenging when shooting at fast-moving targets or in real-world combat where the target can maneuver quickly. The laser beam can even be deflected or scattered by mirror or reflective surfaces, which can be used by the enemy. No one's stopping you from making a missile covered with a mirror surface. Let's not forget that laser systems are very difficult to manufacture and maintain. They require high-precision components and sophisticated optical systems, which makes the cost of their production enormous. And perhaps the last and most important problem that no one talks about is that laser systems can create electromagnetic interference that affects the operation of other electronic systems, which can be critical in combat conditions.
The disadvantage. One is a short range, the other is the sensitivity to weather, and the third is the low kill rate.
Although lasers are an incredibly cool solution, they're still far from perfect. However, all the leading countries are working on improving them, so laser weapons are indeed the future. And perhaps this future is much closer than we think. Just look at the latest developments. For example, the American defense giant Lockheed Martin has completed the development of its 300-kilowatt air-to-ground missile system. Such a powerful laser will be able to protect important objects from artillery, mines, or drones, and one shot costs only $40. But Britain went even further and created the most versatile and impressive laser gun in history. You've probably already heard about the Dragonfire. At least in my videos, I've talked about it, but before that, it was just a small prototype that's finally been built.
The Dragonfire's laser-directed energy weapon demonstrator.
The Dragonfire is capable of shooting down enemy drones and missiles worth millions of dollars, and the price of its shot is estimated at $1. With this system, you can even conduct a war of attrition, because the money the enemy spends on missile production will sooner or later run out. According to British Defense Secretary Grant Shapps, delays in the introduction of new weapons technologies are the biggest waste of defense money. What I want to do is speed up the development process, which usually takes about 10 years, and I want to finish our laser faster and deploy it on ships and on land, he said, talking about the speed of the Dragonfire development. The weapon operates by focusing 37 channels of 1.5 kilowatt laser beams arranged in a hexagonal array, combining them with mirrors to consolidate and amplify power. The output's the same 300 kilowatts as that of the American counterpart, but the cost of use is lower and the effective range is higher, up to 6 miles. The weapon's invisible and silent, as the wavelength of light is invisible to the human eye and is close to the infrared spectrum of light. During the test, the weapon was able to destroy drones and detonate mortars in less than 5 seconds. The Dragonfire instantly turns the metal surface into a 5,000 degree Fahrenheit plasma and can burn through a shell or aircraft fuselage in seconds.
At the leading edge, not just of technology, but in demonstrating the end-to-end capability and inform the UK's future procurement.
Although the system was designed to destroy drones, you must admit that the system is powerful enough to neutralize fast-moving projectiles such as ballistic missiles or even try to destroy a fighter jet. The Dragonfire was first tested at the Hebrides range in early 2024, where it was found that the laser could hit a coin from a distance of 0.6 miles. This briefly indicates its incredible accuracy. Will any drone or missile be able to circumvent such power? I doubt it very much. That's it for our laser adventures. What do you think about this? Will lasers be able to become a new point of support against missile aggression? Or will they remain somewhere behind the air defense systems we're used to? Or maybe you've come up with a new application for laser weapons. Write about it in the comments. Also, don't forget to subscribe and leave your royal like. I really appreciate it. With that, let me say goodbye and wish you a great day.